Hi, everybody, and welcome to this talk, Developing Games with Porting in Mind. I guess I'll start by introducing myself. I'm Ruben. I'm the director of Noble Steed Games, and I lead a bunch of the teams, including our porting team. So we do porting with a bunch of small to medium-sized studios, helping them get their game to other platforms. Typically, studios that have made a game that's on Steam and they want to get on Switch as well. Or other platforms, Xbox, PlayStation, will reach out to us. We've done a number of projects now, so getting pretty decent at porting. This talk is kind of about something that I've seen happen a few times with especially indie teams that we work with, where they're sometimes relatively new to making a game or taking game dev from being a hobby project into a commercial venture, and not necessarily sure how to go about developing their game in a way that makes porting easy down the line. I mean, a lot of teams that we talked to didn't necessarily think that they were going to make versions of the games for Switch or Xbox or PlayStation, but have achieved some level of success or funding and now want to expand the reach of their game, but didn't really set things up in a good way for porting down the line. So really the goal of this talk is to help you know what kinds of things you can do when you're making your game through all stages of the game, so that it's as easy as possible to port your game later, whether you're working with a studio like us or just doing it yourself. There's a sample project that I've made for this talk, and we'll be referring to it a few times. That's the link to it there. But I also just want to quickly touch on two more things that this talk is about. First of all, this talk is going to be pretty Unity focused. Apologies if you're not a Unity fiend like us, but Unity makes porting things pretty easy. And having done some porting work that was in Unreal, I guess my first tip that I'd give to you if you want to make a game that's getting ported is use Unity. But if you don't like Unity, that's okay. I think some of the things we'll be talking about here will hopefully be applicable to other engines, because the second point of what I want to touch on is this talk isn't about the specific aspects of the SDKs for developing for these console platforms. We have NDAs with Nintendo and Microsoft and all that jazz, which means I can't really show you the SDKs, and that sample project that we've got doesn't have the console specific SDKs in it. So we can't really talk about that. And I think it's not really that important, to be honest, because the actual things that you'd be implementing for your game are kind of different depending on your title. What we're really talking about is the way that you can structure your project and some kind of general tips and best practice things you can do to make sure that your game is as easy to port it to any platform as possible, regardless of what that platform is, and regardless of if you ever even do port to a platform or not. The kind of general theme that will be running under a lot of this talk is that projects are easier to port the cleaner they are, which is kind of obvious, I guess, but worth pointing out, right? Like, if your project is laid out cleanly, nicely segmented, nicely modular, that makes your project easier to port. So, this talk is ostensibly about porting, but really what we're going to be talking about is some of the structures and techniques that you can use to make your game cleaner in general, specifically in a way that helps with porting, but also a lot of these things are just helpful structures even if you never plan on porting your game at all. So that's the goal. Let's get into it. Enough preamble. The things that we're going to be talking about here are some of the specifics. We'll be talking about a services model, some input stuff, some save stuff, loading, platform systems, and all those funky types of things. I think this is just a bunch of games that we've worked on different platforms. Switch obviously is up there, but then there's these old feature phones, arcade cabinets, and kind of cross-platform web and mobile stuff. A lot of these systems will help just make your game better at being cross-platform in general, even if they're not being ported to console. But let's dive into it, shall we? Let's first start with services model. So this is not really a porting specific thing, but more just a general setup that I think is helpful to ensure that you're setting your project up in a nice modular way. So what we're going to be starting with here is taking a look at this sample project. This is the sample project that we've got. It's called Porto's Adventure. Very fun. And taking a look at the general model for how we've done a few different things in this game. Why don't I just start with where a lot of indie teams start with is setting up something like a boot scene, right? A scene that kind of initializes things for you. This is very helpful to have when you're making a game that can be cross-platform, because a lot of the platforms have things that need to happen at kind of instantiation. But something that we've seen with a few of our clients is they'll have things that exist inside this boot scene that are kind of required for their game to run. And then, if we want to say start from the menu or start from a specific level, we've had clients say to us, "I'll just go to this level and drop this prefab in, and that will make sure everything's in there." That's not a great system. You want a game that is set up in a nice way that it kind of initializes itself no matter where you start. And so what we typically do is something like a services model that has a kind of self-initializing core, an application plugin, and I'll show off an example of it here. This is the one that we would typically use, something like this, that when your scenes boot up, they go to this application plugin, they let it do its initialization, and then the scene begins. So let's start with an example from our menu scene here. If I go to the menu scene, you'll see I have this menu controller, which is a subclass of a scene controller, and all of our scene controllers do this very same thing. They call this initialize scene routine, which initializes the app if it's not initialized, and then calls this abstract function on scene start. And on scene start in our menu controller just, selects the play button as the first piece of UI. This is a pretty simple setup, but kind of important to understand conceptually for a reason that I think is pretty important when you're porting to console, which is a lot of developers going from working in editor or making builds on their PC kind of overlook the concept that on console things take time to initialize more so than you might expect. So as an example, let's say we're loading up our menu. Something that we've seen people do is load up their save data, for example, in a start or an awake call, and then use that for something on the menu, maybe like populating the options with the volume settings. So you've saved the volume at 50%. When we start up the scene, we need to have that volume set to 50% on our volume slider, right? That's a pretty typical thing that we might see with one of our clients, and kind of overlooks the idea that if you're on a console platform, loading data actually is quite a process. You have to first make sure you're signed in as a user. You have to get the data for that user. Potentially you might have to do other things like mount the file system, and those take time, and they're not going to happen in a start call, right? So something that we will typically do is kind of enforce a system like this that has kind of as part of its initialization asynchronous or kind of async function that waits for things to load. So that's kind of one neat benefit of this services model. In addition to what I was talking about before, where you don't have to like place a game controller in the scene, we're using something like this that lets us wait for the application to tell us when things are finished initializing before things kick off. So that's just kind of, a practical application or two of why something like this model is good. So let's see it in action. Obviously I start my scene, and as soon as we're going to be seeing a few Unity loading bars during this talk, apologies folks. Start the scene, and boom, we've loaded in our application object. It's kind of initialized all of these various services, and then as soon as that's done, it has called this on scene start, right? Maybe it'd be helpful if I jump to a game scene here, because in the game scene, the initialization connects the input for the user. Sorry, let me find it. Where is it? On scene start here. So it calls the player initialize, which means the player can actually move and do things. So on this level scene we've got here, I'll kind of hold the left key as soon as the game opens, but you'll see the player won't actually move for a few seconds as the save data initializes. So I'm holding left now, the scene has started, and then the initialization loop completed. So hopefully that's not too simplistic, but I think it's a pretty good explanation of why you might want to use a model like this, what I call the services model, something that's kind of self-initializing, creates all of its services, and waits for those to be initialized before things are ready to go. So obviously waits for save data or whatever to finish. So that's the first thing that I wanted to talk about here. And if I jump back to this PowerPoint, we're going to see another example of why this is really nice, in my opinion. This is in the player's initialize function, and you'll see they're connecting the input services to move, jump, and interact. We're going to talk about input next. And this is maybe a pretty quick one, but if you're developing a game in Unity and you want to get it to consoles, use the new Unity input system. It's just so much nicer. So if you're not familiar, Unity has an old input system, which is this shockingly ugly thing that's in, where is it? It's Project Settings Input Manager, I think. Here we go, look at that. Where you define your kind of axes and buttons and all this jazz. This is how Unity did their input for a long time, and I guess it was fine, but then they introduced the new input system, which is so much nicer. Lets you bind actions and have all different kinds of like control profiles for different controllers and buttons and all that jazz. If you're not familiar with this thing, you should get familiar with it because it's very good. Not just for console porting, but just for development in general, in my opinion. So yeah, this is kind of a quick tip, I guess, for input. Use the new input system. I'll quickly, I see we've got a question about it. I'll get to that in a second. Just on the topic of input in general, I would say the first step for porting a game to console is making sure that it works with controllers, right? So I guess UI is a good example. The UI actually is pretty subtle. It's actually hard to see the different hover states on these buttons, unfortunately, because I've just grabbed some out-of-the-box buttons here. But the UI, Unity's UI system works really nicely with the new input system, where it kind of automatically detect key presses and navigate selectable components like buttons or drop-downs or whatever. So using the new Unity input system and in combination with Unity's UI system means that you can get controller support for things like UI really, really easily, which is nice. So yeah, I would recommend, if you do plan on making your game available on console, just try it out with a controller and get controller support for things like UI working first, because that will be a really good starting point. So question from Marty, or Alcatraz, I should say. New Unity input system over rewired/in control. Yeah, I mean, so basically before the new Unity input system came out, you kind of needed to use a plugin like Rewired or in control. I don't think you need to do that anymore. I think the new Unity input system, I mean, it's in air quotes new, but it's really 5 years old at this point. It's pretty well supported, and it really nicely works out of the box on all console platforms without you really needing to fiddle around with things like input maps, which are a little bit more complex on Rewired, at least in my experience. I just recommend, I mean, like, if you can get away with using a Unity package over a plugin, you should, because Unity is always going to support their packages more than plugins, right? Until the point which they buy out the the plugin. Question from Elliot: do you make use of don't destroy on load, or do services reload with each scene? Oh, this is a great question. Typically what I would actually do is have an application kind of container that controls all the services that persist across scenes, and that would be don't destroy on load. So then you would have kind of your scene service, platform service, I'll get to these in a bit, input, saves, like obviously scene transitions, input, and saves persist across scenes. You just kind of want one service that works across all of those, because then you don't need to reload data or things like that between scenes. But typically what I would do is have a kind of service container that's an application level, and then maybe a service container that's at a scene level or just at a kind of gameplay level. So that doesn't exist in this project, but what I would typically have is something like a game services thing that initializes itself at the start of a game scene and kind of destroys itself and then reinitializes for controlling elements within a game scene. I think it's a really nice model for doing that. So for example, if we want to have something like all the enemies being controlled centrally through like an enemy service, that might be a service that I would put in kind of the game services container, I guess. Yeah. So I want to touch on something about this services model. I guess I'll just actually quickly take a look at the player controller, because that's a good example of how we're using this services model, and kind of comparing the old input system to the new input system. So this is an example of what the old input system might look like, right? Input get axis horizontal vertical, transforming that into movement, and if get key E, that's interact. If you press jump button, that's jump, as opposed to binding, I guess, events that are being listened to. So on move, on jump, on interact, and those are all kind of passing into their specific functions. So instead of things happening in an update loop, because we don't want things really to happen in update loops without kind of checking that things are like initialized and all that jazz, we have listeners that bind themselves on the initialize, which is called from that scene controller start, and then unbind themselves on destroy. But look how nice this is. Just like app services get input service, boom, 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 done. Or for example, in these warp points, which control kind of teleporting between levels, we have some simple calls to these dictionaries of services. So we're updating the save data, we're saving that save data, and then we're loading a scene with the scene service. So it's quite a nice little way of effectively having references to this kind of semi or pseudo-static container of services, if just from this dictionary, so it's pretty clean to access, and we don't need to worry about like caching the reference or anything. It's very clean to just be like, save this, change this save data, boom, boom. Very nice. Cool. The next thing I want to touch on, I think, is saves. Oh yeah, I guess I'll quickly say, I love Unitask. This little plugin that you can use to really easily create asynchronous function calls. They're so nice. Unitask is one of my favorite plugins. I use it basically in every single project now. Love it. It's great stuff. Look at this. I mean, look at this nice little async change level. Just waits for the save, waits for the load scene. It's awesome. Yeah, thanks Marty for posting that link in there. So, well, I have some other stuff to talk about with the kind of inheritance and dependency injection, all this stuff that we'll talk about, I guess, now, because we're talking about saves, and that's probably a good example that we can use. But this is just another kind of gotcha that's pretty good to touch on. Centralize your save data as much as possible. This is one of the reasons why I like this services model, right? Is because you can see this save service just has very simple functions for waiting for save and load, which can be done asynchronously. And it's really nice to have this centralized. So we have one service, save service, which controls our save data and controls the kind of interfacing with that data. And those are all asynchronous calls so that we can wait for them to happen before we continue on in our game when we're loading from a different scene. Having that centralized is so nice. I mean, like, obviously, I think when everyone starts developing with Unity, they just have player prefs references all over the shop. Just as a quick note, player prefs doesn't work on a bunch of consoles, so you don't want to be using that. But even as a starting point, I think player prefs gets you into this terrible mindset of like, I can access this static data from anywhere, and so you have player prefs calls from all different kind of classes, and it means that if we're taking a game that you've made and porting it to console, I mean, if you were using player prefs, we would have to replace them, but even if you started using player prefs and then changed it to a system where you're kind of writing different blobs of data, you might be accessing and adjusting data from a lot of different places, which is kind of a bad mindset to be in. You really want to make sure that your data is kind of centralized, and that's why I have this save service. Which has one reference to save data, and this is the only way you can get your data in this project, right? Is by going through this save data object in save services. The only way you can save it and load it is going through this service. It's all very centralized. For saves, I mean, you can kind of get really complex with this stuff. I honestly think for most of your projects, it's fine to just do what I'm doing here, which is just, this is the abstract class of this, which is just serializing it as JSON and then converting that to saving that as text in a file. Like very simple. You can obviously encrypt this and get crazier as you want to, and you will want to. For some platforms, you need to save byte arrays or something like that, but I don't think you need to go crazy. I think really the point of what I'm talking about here is like, if you set your system up in a way that things are centralized, and then later on down the road you think, oh, actually, you know, I want to encrypt my saved data, or I want to change it to be a byte array instead of just a JSON file. Because it's centralized, that's really, really easy to do, right? And so that's kind of the moral of the story is centralize things, make things modular, and you can switch them out. And I think a perfect example of that is this save writer class that I've got here, right? So the save service has tries to access a save writer, which is another service. But that save writer is abstract, and you can see I've got this basic file save writer, but then it actually has some overrides. A PlayStation file save writer, a Switch file save writer, and an Xbox file save writer. Those are all blank right now, but I've got them as examples that I'll show off in a second to point out, you know, for each of these platforms you want separate save logic, right? Most of them you'll need to have a logged in user to save data, and you'll need to kind of mount to that user's file system and confirm that you can kind of save data as that user. So each of those platforms will need their own semi-custom logic anyway. So what you really want to do is make sure that you have a system like this where you can have an abstract version of a service. Your save service doesn't care what save writer it has, it just cares that it has one that's initialized, and you can plug that in later with a different platform service, which I'll talk about in a second. So this is another kind of advantage of the services model, is you can like swap out different, I guess, like abstract versions of services to make things really, really easy for different platforms, which is nice. The one other kind of quick tip that I want to give while we're here is, it's so good having a boot scene. Always have a boot scene. I mean, boot scenes are just like wonderful. You should always have them. What are they actually going to do if your application is initializing itself from anywhere? The answer is probably not much. They're just going to be a dedicated place where your game can start, and that's always really nice. You might want specific things that you want to do when your game boots up that are kind of custom from here. You might want to be kind of contextually loading different application prefabs based on if this is like the demo or the full game or all kinds of things like that. So it could get more complicated, but just have a boot scene. It's like a great thing to do. The projects that we've ported that haven't had boot scenes often become a little bit chaotic because you need to do things like loading data before you get to your main menu potentially, or all kinds of things that just could cause problems. I guess the kind of corollary to this is try not to use awake or start unless you really have to. I mean, it's probably fine for like visual elements that don't rely on anything other than themselves, but you should kind of never assume that something is accessible to you on awake or start. If you're using a services model like we're talking about here, you can always have something like your game scene controller, which initializes things after the applications have spun up, and that means that everything will always have access to pieces that it needs, right? I mean, like, I think the volume slider example was a really good one that I mentioned. I've seen so many projects where, you know, for example, they might have a boot scene, they've set up their menu as well, and then, you know, on their menu scene, their options menu on start looks for the, you know, the key in the data for the save volume, or sorry, for the options volume or for the music volume or the sound volume, and initializes the slider to that value. That's like a classic thing that people will do that will always throw an error the first time you try and port it because save data takes time to load. So just in general, try and steer clear of start or awake for things that potentially rely on something else, because you never know when something will take longer than you anticipate. You know, when something that's can be done within a frame on PC has to be a kind of asynchronous call on a console. So just steering clear of that in general is a good idea. Loading. So loading is another thing that's really nice to have in its own service. So I think I've got in here a scene service, which is so basic. But again, similar to what we talked about for the save service, like, it's fine that it's basic because it's the central place that loading goes to. So this one is just a load scene async function, which literally just calls like scene manager.load or whatever, right? Scene manager.load scene, right? It's doing nothing at all in this scene service, but that's okay because it's centralized. And so down the line, we might want to do things depending on the platform or depending on what we're doing, like turning this into asynchronous loading, or turning this into loading asset bundles, or transitioning to a loading scene, or doing a fade in and fade out. So we kind of centralized our fades and made them consistent across loads, or displaying like a little spinning wheel in a loading icon, or all kinds of things that we might want to do to add complexity to our loading system that we haven't thought about at the start of our project, get so much easier if we're centralizing our loading, right? I mean, yes, this is not really a task right now because this is just a sample project, but in the future we might want to do something like, okay, fade our fader in, transition to loading scene, display, loading, wheel, graphic, then kind of wait for async scene load, then, fade out, loading wheel, graphic, whatever, right? As an example, this is a very simple scene load that we'd start with, but we might want to completely change it over the course of development of our project, and even change it much later into the project when we're starting to do porting. So you want to have things centralized. Centralize things into services, and then you can go crazy with them down the line without having to worry about, okay, well, we're loading things in a number of different ways, so now we need to be changing a bunch of different load calls. So yeah, I guess that's just a nice little thing that's especially worth mentioning, because for console porting, there are a lot of upgrades that you might need to do to your loading scene. So to your loading service or your loading sequence. So things like addressables are a perfect example. Depending on the platform, you might really want to implement addressables to cut down patched size, or to cut down the size of your executable or whatever. So having a centralized service so you can do that is a real boon. And projects where you don't have that makes things a lot tougher. So centralize things, especially your loading. It's very important when you want to get to console. So I guess one of the other things that I will touch on now is like platform subsystems. And this is going to be another example of when our services model becomes very helpful. I mentioned the saves previously as an example of one of these things that we can switch out, but let's actually take a look at that, shall we? So if I boot up my game here, we'll initialize all of our services, including our platform service. So actually, this is a bad example. I'll show you the prefab before it's initialized. It's got this platform service, which only has one thing on it. Sorry, it's got this platform factory service. And what that platform factory service does is initialize all of our other services, dependent on what platform we're on, of course. So if we're on editor, we create and initialize our editor platform service, standalone, Switch, PS5, whatever. Those platform services have their own initialize, and that does things like add a file save writer. Or if we're on, well, let's take a look at some others, but they're all pretty similar in this circumstance, I think. The Switch one, for example, will add the Switch file save writer. And so that save system, as I mentioned before, only really cares that there is a save writer service initialized. The platform services are responsible for adding their own versions of it. And the reason that that's really nice is because there are a lot of different things where you want to switch out different versions of a service without necessarily any of the rest of the logic caring what that service is, right? So one clear example is achievements, right? All kinds of different platforms use achievements. So standalone, if we're deploying on Steam, would have achievements. PlayStation would, although I think they're trophies. Xbox has achievements. I can't remember. PlayStation is trophies, Xbox is achievements. But Switch doesn't have achievements, right? Switch achievements don't exist. So what we might want to do is have something like on Switch, we create a Switch achievement service, which just effectively does nothing. Maybe just logs to a file, hey, we tried to unlock an achievement. On PlayStation, it will fire off the PlayStation call for unlocking an achievement, but on Switch, it doesn't do anything. But regardless, what we can do then is have our code still reference that service. So let's say, we want to unlock an achievement here. We might do get achievement service dot unlock achievement 1, right? Whatever. It doesn't matter to the code what that achievement service is, whether it's the PlayStation achievement service, the Steam achievement service, or the kind of no achievement service that we might implement for Switch, this code should still be doing this, and it's up to the service to handle its own implementation of these achievements. But this way we don't need to have any kind of like, achievement manager or anything like that. We can just very easily fire this off, and all these services can do their own thing and handle themselves completely independently and modularly. And the only place where we need to use any custom defines is in that factory that has added those different services. So that's really, really nice. And I think a really good example of how you can do things like this. I think this can be taken out to a really, really extreme level where you're having things like, if I was going to develop for console, I'd have probably a user service which manages the logged in users. And that gets pretty complex because on some platforms, on some consoles, you can have multiple different users logged in, and multiple different users should be able to progress their own achievements while they're logged in. So you want some real complexity to come out there. But then we might also have things like cloud storage services, for example. So maybe on Steam, we use Steam's cloud storage. We use kind of cloud storage on PlayStation, but on Switch, we don't have a cloud storage service. We want to hook into quite complicated different calls and handle things that can be quite complex, but having them all contained in their own services makes things very, very easy to handle, even if things get incredibly complex, like these kind of cloud saves or different leaderboard services between, whatever, Steam versus Apple Arcade versus, something like Switch that doesn't have leaderboards. There's a lot of complexity that consoles have just by virtue of having their own weird little requirements for different things. So building a services model like this that allows you to swap things in and out is very, very nice. So with all that in mind, I guess I'll just kind of quickly run through some of the services that I've put together for this very basic application, game, I should say, for Porto's Adventure. And then we'll just kind of take a quick look at it. But yeah, there's nothing too complex that I've set up for this project, again, because I can't legally put any of the actual platform SDKs in here. But hopefully it's helpful as an illustrative example of how you can use things like services model and how you can handle all of these specific cases that you need to worry about for porting. So here's my game. Here's Porto's Adventure. So this is Porto. He runs around and he jumps and spins like a helicopter. When you press E, he moves to the next level if you're inside the warp box. Oh no, I've got a bug. I think I unchecked a scene from my build. Yeah, that's weird. How did that happen? Well, let me just put it back in. So if I was developing something more complex, come on, man. What did I just move it to? What am I doing? If I was developing something more complex, I would be kind of using addressable scene references here and not just chucking these directly into the build settings. But for a simple project like this, I've just gone with a simple option for a lot of these things. But yeah, let's show off this beautiful game that I've made. Porto's Adventure. Oh great, so it had saved that we were at level 2, even though it failed to do that load, so we loaded in at level 2. And here we go, back to level 1, do a little helicopter jump to jump around, and back to level 2 again. So yeah, this is a pretty simple little thing, but I think a nice example, especially for the save data writing there, of just seeing how we can use different save interfaces on different platforms. So obviously, because we're on editor, our platform service has initialized the editor platform service, which creates the file save writer, and that has saved and loaded our data automatically. And now, of course, if we were to make a PlayStation or a Switch build, it would instead load the PlayStation or Switch platform services, and then those corresponding save writers based on that. So yeah, just a overview of how you can do some of this stuff to set it up, but hopefully helpful. A comment from Alcatraz in chat: handy doing it this way, since you can still fire off data to your own backend or analytics if you're on a platform that doesn't support various things. Yes, for sure. I mean, and that's another great example of you might implement something like a PlayFab analytics service, But then if you're on, a different platform, you might want to use those platforms' specific analytics services. Or, for example, if you're working with a publisher who has their own analytics service for the PlayStation version of a game, you would have, your, let's say, PlayFab analytics service compared to your publisher analytics service, depending on different platforms. It's all very helpful. Your code will always be firing those analytics events, but you'd be handling them different ways based on your platform factories and all that jazz. So it's very nice to make your code kind of modular and clean. And it also really encourages good principles in the sense of forcing you to have your code be kind of modular and self-contained, which is nice. I find setting up things like assembly definitions really helpful because they force you to have good code. You know what I mean? Like, it's frustrating setting up an assembly definition late into the project and being like, oh man, my code here just is referencing this other thing that it shouldn't be referencing, and I can't allow it to reference that definition because it will make an infinite loop of assembly definition references or whatever. And it just kind of reveals to you that you've set up your code in a way that's actually kind of flawed, and that you can kind of skirt by with that when you're at the stage of just developing for PC. But this stuff becomes so much more important when you do console porting because it becomes enforced to a much higher degree. Good question from Bilal on how granular do you go with asm-defs? I don't think you need to go too granular. I mean, like, on this project, I've just got one for scripts, but I will often do more complicated ones. Do I have a good example? No, not really, unfortunately. I'll often do more complicated ones if I've got kind of different discrete areas of a game. The splitting asm-defs for like logic and UI and rendering, it can get painful. I would encourage doing that if you're doing something like multiplayer development, maybe where you have dedicated servers and you don't want your dedicated servers to be displaying UI because that's just chewing up bandwidth that they don't need because nobody's obviously looking at the UI on a dedicated server. So in that circumstance, you might want to do something like that because you might want it to be kind of enforced that your game server doesn't have the UI asm-def, and therefore you can kind of make sure that everything will function correctly on the server. But for typical kind of small team game development, I think it's probably fine to just have maybe one or at most a small handful of asm-defs for your core scripts. I think that's okay. What I might do is something like a core asm-def where you have, all your core things like the services model or this application container, and that's kind of independent because it's the kind of sub-engine of your engine, and then kind of asm-def for the rest of your game that's controlling all the logic for everything and things like that. What about dialogue systems such as Yarn Spinner that have their own built-in saving systems? Should we avoid using those to store data? I mean, for any different kind of plugin or tool that you're using, you should check the compatibility it has with other platforms. I think something like Yarn Spinner that's like loading in JSON data or whatever, I'm kind of comparing it to something like Ink in my head, which I'm a bit more familiar with. It can be made to work, that's fine, especially if it's kind of data that is bundled and you might need to worry about it storing its own data. But I mean, the other thing to worry about is you might just need to build a custom something to allow the data storage to work. Really the advice I'd give you is see how modular you can that plugin is. If you're allowed to plug in a different save system to something like Yarn Spinner as an example, that's a good sign. That means that you'd be able to make it work pretty easily on console because you can just hook it into your own save system. And that's not just helpful for like porting conversations, but again, as has kind of been the theme of this talk, is quite indicative of like good coding principles in general, I suppose. I think something that's really stuck out to me about porting work is it really does mandate that you have better and better coding practices than you might get just starting out. So yeah, I mean, I would encourage you to kind of explore that stuff yourself as a way to just improve your own programming knowledge, I guess. We've kind of segued into Q&A, so let me put up the Q&A slide because we have a nice little graphic for it. Does anyone else have any other questions about this stuff? I know I've been kind of rambling through a bunch of different technical pieces. So if there's anything that I jumped over really quickly, of course, feel free to let me know, and I'll go back and kind of give it a bit more of its time in the sun. But yeah, the goal for this talk really was to make sure that I gave a foundational understanding of what some of the common pitfalls that you might see when you take a project that you have developed without porting in mind and try and port it, and how you can design your project in a way that avoids those pitfalls. Just to quickly cover it, the main thing that we talked about is something like a services model, where your game kind of initializes its own self-contained application, which has independent modular services that can kind of control each individual piece. So for example, input or saving being kind of controlled in their own individual service, so that they are centralized, modular, and easily switched out based on different platforms. Basically, is the kind of 5-second summary, I suppose. Well, let me just finish up by hitting with some fun little bugs that we've hit from our time porting. One of the craziest bugs that I've ever seen is a bug that seems to be pretty common on Switch, which is that if you hold down a bunch of if you hold down 4 fingers on the screen during a game's initialization, there seems to be a bug in the Indie input system which makes the game crash. That's something that we've run into once or twice from different projects, and it seems kind of crazy, but it's a great example of the kind of bug which you would never think would actually happen in real life, right? But really sometimes does, and that's really the strength of a model like this services model, is because if you have all your input centralized, it means you can do a workaround like the one that I think they ended up suggesting, which is have the touchscreen disabled to start and then enable the touchscreen after your app has initialized, which is like a crazy thing to suggest for a Unity bug, but I guess that's just life. And that's only something you can have if you have a nice modular system that controls things like initialization and loading like this. So yeah, just I guess that's a good example. Would the services model support multiple services for a service, e.g. multiple analytics platforms? I mean, yeah, totally. Like, you know, I guess I've used this save service as an example. It's got this save writer, but if we wanted to do something like support cloud saves as well, we might have, you know, our local save and our cloud saves. And so the save call would go like, you know, await cloud save, then await local save, oops, and then maybe like, you know, perform save reconciliation or whatever, if there's a difference between the two. And if we're talking about multiple analytics platforms, it might be, you know, we send an analytic and then, send an analytics event, and then that could send that analytics event to an array of sub-services that we have initialized. I think the thing that's nice about this is it's such a modular model that you can really kind of use it for all kinds of different things in a really nice way. Yeah. It's a good example. Mobile publishers always want you to implement their SDK so they can do some analytics on your game. So having a model that allows you to kind of plug in and switch out a bunch of different analytics platforms that all just have the same simple set of, like, you know, log in, register with this analytics service, start sending analytics events, kind of confirm that they've been sent, whatever. Yeah. Are there rendering concerns from a platform point of view, shader techniques, etc., things to avoid? I mean, yes, I suppose, but it's quite specific to the game, I think. I guess the advice that I would give is whenever we do porting for a project, what we do in the first week is get it running on device, right? Even if it's kind of glitchy or save data doesn't work fully, as a way to just kind of confirm whether things will break. There isn't really a good way to know if a shader is going to break on a platform without trying it out, but I think you're probably not going to run into that with just the basic, like, standard plugins that you might use. I think Unity supports all of these console platforms pretty nicely, and what that means is unless you're writing your own shader which is doing something really wild, you're probably not going to run into issues, I would anticipate. It kind of depends on how crazy you're going, I suppose, but for, I guess, indie game development, it's probably something that you don't need to worry about unless you're trying to push the envelope in a specific way, I guess. Yeah, I mean, like, look, Unity's got its problems, but it is pretty nice sometimes as well. Yeah. Do we have any other cues from the crowd? All right, well, I think that's it then, folks. As mentioned, this sample project is available online, so you can fully steal the plugins and services model that I made. In fact, I kind of made it, just to touch on the architecture of this project a little bit, I kind of made it its own thing specifically for that reason, so that you could steal it if you wanted to. So if it's helpful as a starting point, you can totally just take a reference from this and try it out. It's in this little plugins NSG tools folder, just a stripped down version of the services architecture that I used in one of our other recent projects. But yeah, thanks gang, thanks for joining us. Last chance for questions, yeah. Well, of course, if you do have questions, you're all in the Discord, so you know the right place to put them. But yeah, or just reach out to us and check it out. Oh, a new question, a kind of unrelated question from Bilal, but let's tackle it. Thoughts on auto testing in Unity? Do we do it much? No, to be honest. I mean, so we used to, in fact, Marty, who was in chat, used to have a little testing thing that he would use to kind of stress test mobile projects, I suppose, which is basically would just spin up a bunch of instances of a game and click things, which was kind of fun. Unity has its like unit testing library implementation now, which we've used on one project, and I really liked as a way of kind of validating things like no missing references on components. So you'd forgotten to assign a transform reference or like whatever to a component. You can write a unit test that can catch that pretty easily, which is quite nice. But I honestly haven't found that unit testing in Unity has been that useful. Maybe outside of some specific, like quite mathy applications of things. I was writing a script recently to like check if points were in a kind of custom polygon, and that's the kind of mathy thing which I might write a unit test for, just to validate that I haven't fucked up my math at some point. But yeah, I don't know. We for porting, we typically do a lot of QA just because porting always has problems and you kind of need to find them with a human rather than set up unit tests that might catch them if you know exactly what you're looking for, I suppose. So in short, we don't do much unit testing, or I guess you asked auto testing, but in my head I'm kind of conflating. Not within Unity. When we do kind of server-side work, we'll do a lot of unit testing because that's a lot cleaner to set up, but yeah. Odin's validator is great for validating reference. Yeah, I love that. Good call, Elliot. Yeah, the four fingers on the loading screen, right? Like that's a perfect example. There's just so many weird things that come up with porting, and there's like, okay, test cases for like what happens if somebody disconnects a controller, reconnects a controller, blah blah blah. Like all these specific things, which it would actually kind of just be a nightmare to write tests for. In fact, what we actually do instead is just write test cases for our projects, right? Like documentation of here's the tests that should be performed by a person, and maybe some of those could be automated, but in the whole it's like, register a user, go to the screen, change this. Like test plans are nice as the human side of automated testing, I suppose, before we kind of call a build, valid and ready to submit. Okay. All right, cool. Yeah. All right, folks. Well, thanks for joining, and good luck with all your games, and hopefully porting them goes smoothly, and have a great weekend.